We will learn about Kubiya. Kubiya is an AI agent tool which helps you out to integrate with your different account like AWS, Kubernetes, and GitHub. So right now we will focus here on the GitHub account. So the what exactly we will do is we will first create a Python a Flask Docker application, and then we will try to make that application and Dockerize it, and try to push the Docker image to the GitHub container registry. And I've given you a readme how exactly we can do this. So if you see here, I've already created the application, the app.py, and then there is a Docker file which is linked to it. And we will also have a GitHub Actions where we will try to push the Docker image, and also we will put a failure where the pipeline fails. Now the whole use case here is when the pipeline fails, we want Qbia to go and talk to my failed pipeline and try to get the details why exactly the pipeline failed and what are the reasons for it. So that's the main gist of it, and also ask Qbia to go and trigger the same workflow, and then from the Qbia AI, and see how exactly it triggers that workflow, and again it fails, and it tries to get the details and the analysis why it fails and what are the next steps for it. So I have already created this app here. Now let's go to this. It's a very simple app here. What it does, it has two endpoints. One is the root endpoint and one is the health endpoint. So when you hit on this, it's available on the port 5000 on your Docker, or and at the same time on the host machine, and it basically uh, displays the message as the hello or Docker world. And if you hit on the health endpoint, it will basically give you the status is healthy and the service is up and running. So that's a very simple Python application, and then the corresponding Docker file is here. And in this Docker file, if you see here, we are trying to get the base image of Python. And in this work directory, we have the app or work directory here, and we are trying to copy the requirements.txt, and also we are putting the app.py, which is the application, inside this inside the working directory. And then we will be running the requirements.txt file to install that requirement, which is nothing but a Flask here. Yeah, so this is a Flask application, and this is the requirement, which will basically go and get this dependencies from the internet. And then this is the testing application file where it will go and if you see here, it will go and invoke the application, and the data which is expecting here is if I hit the root endpoint, then I should get the hello Docker world from the application. And so this will basically go and invoke this application app.py, and then here it will go under the root the path. And if you see the message I'm trying to return here is I've introduced this is to break the flow, and if I don't want to break the flow, I will give the hello Docker world, and it will go as a happy path scenario. And if you want to break the scenario, then you have to exchange the message and return in the response here. So this is at the high level, the application, and this is the Docker application. Now let's go, and I will show you how exactly I have done all those installation and everything. So just wanted to show how exactly it can be executed. So I've done a couple of executions here. So let's do one more execution on this. So if you see here, so yep, this one. So I'm trying to So I will clear my screen here, and let's again go back to the README, which will give us the context here. So on the README, we have to go and install first everything, like I've done here. You can clone it, you can have a virtual environment, you can install all the dependencies, and then finally you run the application here. So let's run this application here. Go back here, and I'm running this application. So if you see here, yeah, this is what I got it. And then if I go on this local host and I try to see what exactly I get here, so I just go and hit on the local host. So this is what I'm getting here. This is a message I'm getting, and this is the host name, which is my local laptop. Okay, going back again to read me. Let's go here. Okay, so this is my yeah, this is running the test, so we can run the test and see how exactly it behaves. So in this running test, if you see here, I'm calling test underscore app, which will basically go and call my app.py file, and it will see what exactly is happening here. So let's go back again. I will say Control C, and I will say this one. So if you see, this is basically calling my root path here, and the root path I'm breaking it because I'm giving the message, and which is not equal to the message which the application is expecting, and that's the reason it breaks here. Okay, so this happens on the now let's go on the Docker side. I've already built a Docker image, and let me run this Docker image again. So this is, I'm running a Docker image here. Okay, so my Docker image is running here. Now I'm trying to use the access the application from my uh, yeah. So if you see here, hello Docker world, and this is my host name, which is nothing but a inside the Docker. And if you saw initially, it was my laptop. Now this is basically inside the Docker, which is the host name of the container. Okay, and going back again. Okay, now this is a basic setup with the Python, and independently I've run Python, I've run the Docker, and now I'm running the you can run the pipeline also. So I've already created a pipeline here. If I go here, and this is my pipeline, my my CI/CD actions here. So again, it does the exactly same thing. So now here it will go and check out my code here, and once it does a checkout of the code, it is setting up the Python, installing the dependencies. If you see here, and then finally running the test, which I showed you from the command prompt. And once this fails, this will not go and push the Docker image. If you see here, this is basically logging into container, and then finally building and pushing the Docker. So if it goes through fine, then it will go and push the Docker image to the GHCR, which is the GitHub container registry. So if I go and show you on the actions here, since I've introduced a failure scenario, it doesn't push the Docker image, and it and the pipeline fails here. Okay, so if I see this pipeline, yeah, it fails here because what I've given here, we have seen the same assertion. Because the message which I'm returning from my application from my test is basically not equal to the hello Docker world, and that's the reason it will break, and it will not go and push the image to the GHCR here. So up till now, what we have done, we have run independently Python on the command prompt. Then we have run Python within the Docker, which I've showed here. So this is a Dockerized image of the Python. So I'm running this within the Python, within the Docker image, and then finally you can run the same thing from the GitHub Actions. And this is what we are doing in the GitHub Actions. Now, talking about Kubiya, without Kubiya, someone has to come here and understand, okay, what exactly happened on this run test, and what was the reason why it failed. So someone has to go and manually log in and understand all these specific things here. Now with the Kubiya, what we can do is on the Kubiya, if you see here, there is a concept of a use case. Now, once I make a use case here, this use case, what exactly we are doing here is we are connecting the agent, and this agent basically is going and talking to my GitHub Actions, and trying to get all the details from the GitHub, what exactly happened and why my specific run, workflow run or GitHub action run failed, and what are the next steps. And it does a detailed analysis of the failure on the GitHub side. So this is one of the this is the agent which I've created. Now it's very simple. You go on the new use case here, and you select the first one, which is CI/CD maintenance queue. And if you see here, it has a very detailed documentation here, how exactly you can go and create a CI/CD agent here, and what are features. This is all the features where you can use all these features here for this specific agent. And this is all the configuration details is given here. And if you see here, this is very simple steps given here. You can go to the app, then you can go to teammate, create a use case, and then give a name to the use case, and then finally select all these details here. The important part here is your GitHub token, which will go and talk to your GitHub account. And then you have an inbuilt runner, and you have a repository list, which exactly which repository you want to go and talk to, and you can give multiple lists there, and your org name. So I will show you how exactly you can do it. And yeah, that's it. Once you have done, you can go and deploy the agent, and then agent is able to talk with the help of this GitHub token as well as the repository list, and then get all the details about what is happening on those specific list. And this is what exactly it can do. It can also run the security check. It can do all the detection of the YCICD, detects the slow pipeline and what is failed and everything. It can give you all the details here. So let's go back and create a use case here. So I will say test, and I can say test CICD agent, and I can give my repository name. This is the repository where I showed you my CI/CD pipeline failure, and this is any GitHub token from your account you can give here. I will just say here for the sake of giving a detail here, I've given you, but copy the exact GitHub token and make sure when you create a GitHub token, these two things are very important. Your access token should have rights over the repo, and at the same time should have the admin rights over the repo hook permission. This repo hook permission, and this is very important when you create this GitHub token. So it will create a webhook on the GitHub side, and that basically captures all the execution and the workflow run and feeds to the Kubiya agent here. And then you have a secret GitHub token. Again, this you will create a token here. So let me go back to my screen here, and let me show you what exactly I mean by that webhook. So let's go here. And if you see here, there is a webhook here, and it creates a webhook here, and with the check run and the workflow run. So it creates a webhook here too. So to access this webhook, it needs that GitHub token, and at the same time, if you go down and if you see the secrets here, there is a GitHub token secrets here. If you see a GH token, and this is exactly same GH token which we are talking about here. So these two tokens can be same, but make sure you have the proper rights, and then give those specific a token here. At the same time, the webhook will be created automatically when you start this use case, when you start and create this teammate here. And then you have a default runner here. You can choose a runner which is given by Kubiya. So this is where the exactly you create the agent, and once you say save and continue, it might break here because I've given an invalid token here, but let's see. So this is how you create a teammate. So this is creating a teammate, and this teammate is getting hooked up with your GitHub with your GitHub account, and has the visibility of the repositories where you are trying to get the details. So I've already done this. This was just a sample here. So going back to the actual execution here. Now, if you see here, I've asked Kubiya. So now when you go on the Slack, this is a Slack integration where you can go and ask your this is the agent here, and you can say, yeah, you can go and invoke all the details and talk to Kubiya. So it will respond back to you. Okay, so it will open a new thread, and in that thread you can go and ask the questions here. So the way I have done here, if you see here, I've given the run ID, the branch name, and the details here. Why exactly my run ID is failing here. So if you see here, it has given me all the details. These are the details of the failure. Why exactly my Flask application is failing here. And if you see here, this is given exactly same thing because the messages are not equal, and that's the reason it's failing here. And this is the details here. Now what are the next step is basically to review the code, update the test, and then fix the implementation if required. So this is again a very good agent where amazing features are given here. You can directly go and talk to the specific repo. You can trigger the workflows. You can give the workflow ID and get all the details and do the analysis here, just by using the NLP and using the prompt, a good prompt here. So now if you see here, I'm asking again, can you trigger the same workflow? So again, it's going and trying to trigger the same workflow here. And see, if you see here, I've given the org name as well as the repo name here, which I showed you on the use case, which is nothing but a teammate. And then it's making is going on my CI/CD YAML file, which is on the main branch, and it's trying to trigger the workflow here. So it's going here on my workflow. It's going here, and then it is trying to trigger the CI/CD YAML file with all the details which I've given, and using the token, and then trying to again create the workflow here. So this is the overall approach of the Kubiya, how exactly you can use it, and try to talk to your GitHub Actions, trigger the workflow, get the details, do the analysis, understand the next steps, and see exactly why it is failing. So it's very smart enough to go and check the logs and get the logs and see what exactly and why it failed. So this is pretty much about Kubiya, and it's a very nice AI agent which can make your life very easy. Similarly, you can do an integration with the AWS, with Kubernetes, and different connections you have on the Kubiya available. Try to use it, and try to understand how you can integrate the AI agents into your DevOps flow, which makes your life very easy. Thanks, guys. Take care.